Hello, this is Dr. Me at the Actuarial Academy again. We're looking at a bona fide actuarial type problem where a physician has studied the medical history of 977 men who died in 2011 and found that 206 of these men died of causes related to prostate cancer. In addition, 316 of these 977 men had a father who developed prostate cancer. Furthermore, of these 316, 97 died from causes related to prostate cancer. And we are to find the probability that a man chosen randomly from this group of 977 died of causes related to prostate cancer, given that his father suffered from prostate cancer. So, at the first reading of this problem, it does seem a little overwhelming, at least it does to me. There's a lot of numbers up here, and the final question says to determine the probability that a man chosen randomly from this group died of causes related to prostate cancer given. So this is very, very important to understand that it's given that his father suffered from prostate cancer. So before we solve this problem, there's a couple of background facts we need to know and also make use of in solving this problem. First one is the concept of crosstabs. So crosstabs have been around forever. Well, I guess not forever. I think since the early 1900s, 1904, I believe Pearson first introduced these. And crosstabs are very, very powerful in that they provide frequency distributions of multivariate data in tabular form. And you can very easily identify what characteristics of the multivariate information each person in the group has. And so we'll actually build a crosstab from the data given up here. Another fact we need to know is conditional probability. The probability that A occurs given B has occurred is defined as the probability of both A and B divided by the probability of B. And so just a quick review of why this works. Basically, if you know B has occurred, then probability of B is in some sense your reduced sample space. And so since you're trying to determine the probability of A, you need to intersect A with B to figure out how much, okay, in quotes, of the probability of A is in probability of B, and this is then a probability of A given B. So before we actually begin solving the problem, we always, in problems like this, where we need to define events, we do. So we'll define PC equaling the event died of causes related to prostate cancer, and we'll define the event F as father suffered from prostate cancer. So in the context of the problem, these events should be clear. So in problems like this, where they state so many men died in a given year, and of those a given number died of prostate cancer, and of those had this characteristic, so forth, I wouldn't recommend diving directly into direct probability calculations, although you could, but you need to decipher this first and translate what seems to be a little confusing to something that's very easily interpreted, and that's again where we will use crosstabs or cross-tabulation. So let me just write that down here, and that's what we'll do to get a grip or a handle on this problem. Okay, and so this is going to be a 2x2. These are also called contingency tables, by the way. And so I'm going to draw a 2x2 square. And the reason why we know it's 2x2 is because if you read the problem, there are really two characteristics that we're talking about: dying of causes related to prostate cancer or not, and father suffered from prostate cancer or not. And so let me label this here PC. This column will represent those that died of prostate cancer, and this column will represent those that did not die of prostate cancer, and this row here will designate those that had a father that died or suffered complications from prostate cancer, and then this row will represent those that did not. And we'll try to fill this out based on the data that's given. And we'll also put totals here as well. And totals here. Okay, so let's see if we can fill in this contingency table or crosstab table. So a physician studied the medical history of 977 men who died in 2011. Okay, so now we have an understanding of our population, so to speak, and found that 206 of these men died of causes related to prostate cancer. Okay, so that means that in this column here, PC, we're going to have a total of 206 people. Now, we don't know if their father had died of complications related to prostate cancer or not, so we can only really put the total right here, okay, in the hopes that we can figure out what goes in these cells in a moment. Okay, so we have that much figured out. In addition, 316 of these 977 men had a father who developed prostate cancer. Okay, so we are given that 316 of these men, of the 977, had fathers that did develop prostate cancer. So that would be this row right here. So we would know that a total of 316 of the 977 would actually fall in this row. Again, we don't know where or how many actually died of prostate cancer or not right yet, but again, we're going to figure that out. And then, so another item we can determine right off the bat is actually the total number of people that did not die of prostate cancer. And we get that from the fact that we know that 206 people died of prostate cancer, so that means that the remaining 771 did not. So that's just 977 minus 206. Okay, now let's continue reading the problem. Furthermore, of these 316 that had a father who developed prostate cancer, 97 of them died from causes related to prostate cancer. So what they're saying is, of these 316, 97 died of prostate cancer. And so that implies that 219, or the remaining of the 316, did not die of prostate cancer, of those who had a father that did suffer from prostate cancer. So that takes care of that row, and we can literally finish up the remaining rows by just subtracting the total minus what's given in this cell here. So this would actually be 109, and this would be 552, because we know the remaining have to be associated with that cell, and we can actually complete the row total on that. And just to double check, and I'll let you do that, you need to make sure that the row totals and column totals sum to 977, and that all these sum to 977, so that everything works out. So this is our crosstab for this problem here. Now this is very easily interpreted in that we immediately see, okay, out of the 977 people, 97 of them died of prostate cancer and had a father who suffered from prostate cancer. 219 of those did not have prostate cancer, but their father suffered from prostate cancer. So there's a lot of questions that can be answered straight from this crosstab. But what the problem is actually asking for is find the probability that a man chosen from this group died of causes related to prostate cancer, given that his father suffered from prostate cancer. So in terms of the notation of the problem, what we're looking for is the probability that a randomly selected man suffered from or died from prostate cancer, given that his father did not suffer from prostate cancer. So notice I'm using F complement. So that refers to this event here, but the complement of it. Where F is father suffered from prostate cancer, F complement is father did not suffer from prostate cancer. So using our conditional probability here, we see that's defined as the probability of the event PC intersected with F complement, all divided by the probability of F complement. Okay, and this is equal to, so let's just work the top piece first. So this is the unconditional probability that a randomly selected man died of causes related to prostate cancer and his father did not suffer from prostate cancer, and that would be this cell here. So the men that died of causes related to prostate cancer whose father did not suffer from prostate cancer, that's the people in this cell here, 109. Okay, but we want the probability of that, so that's really 109 divided by 977, all divided by the probability that a randomly selected man's father did not suffer from prostate cancer. Now that turns out to be the entire row here, where we actually have the sum total here is 661. So that's 661 divided by 977. And that's just equal to, of course, 109 divided by 661. So in terms of decimal equivalent, that's about equal to 0.165. Okay, and that's our answer. Thank you very much.